Alright, we're back for the next installment of example problems for the Math Toolkit final. Next time we're looking at a recurrence relationship, and because I like story problems, I've made this one into a little bit of a story problem. So it says, Sally now has $1,000. Every year Sally earns 10% return on the money that she has and then deposits another $500. How much will be in the account in 50 years? Construct and solve a recurrence relation to find out. So we've been normally solving recurrence in terms of using C for our series. So we'll continue doing that. What do we know from the problem? That the current amount she has is $1,000. So that is my C sub 0 is 1,000. And now we're told what happens at the end of each year. At the end of each year, so this would be C n plus 1 for the end of this year, the start of the next year. And she earns a 10% return. What does that mean? It means we take the amount she has at the end of that year and we multiply it by 1.1. She keeps all of the original money that she had, that's by multiplying it by 1, and then she gets a 10% return, so 0.1 is there. And then what does she do? She deposits another $500, so plus 500. And it's not immediately obvious what's going to happen to that after 50 years of doing this process over and over and over again, doing that 50 times. But let's write down the first few of them just so we can start to see what the pattern is. So here's n, that's the number of years from now. And here's C sub n, which is the amount of money that Sally has after n number of years. So when n is 0, C sub 0 is 1,000. We were just told that in the problem. Well, what happens after year 1? Well, we take that $1,000 and we multiply it by the 1.1. 1,000 times 1.1. And then we add 500. 1,000 times 1.1 is 1,100 plus 500 is 1,600. And that's how much you'd have at the end of year 1. At the end of year 2, this is I guess the start of year 1, the end of year 0. So here's the start of year 0. What do we do to get from year 1 to year 0? We take whatever there was at the end of year 1 and we multiply that by 1.1. So that's going to be 1,000 times 1.1 squared, that's that times 1.1, plus 500 times 1.1, which is that times 1.1. And then what do? We need to add another 500 plus 500. And what does that work out to? Well, this times 1.1 is 1,760 plus another 500 is 2,260. And let's do year 3. We get year 3 by multiplying year 2 by 1.1, so we have 1,000 times 1.1 now to the third, plus 500 times 1.1 squared, plus 500 from here, times 1.1. I'm going to write that to the first, so that the pattern becomes more clear, plus 500, and just to make the pattern really clear, anything to the 0th power is 1. We can multiply things by 1 whenever we want to. So instead of just calling this 500, I'm going to call it 500 times 1.1 to the 0th. And a little bit of arithmetic that I did earlier so I can do the video more quickly. All of this works out to 2986. All right, So what do we see here? I think the pattern is starting to become clear. Every time we take this 1,000, and we increment n by 1, we're going to raise 1.1 to a 1 higher power, and that's, if you see, we did all with it down to 50. At the end of this, we'd have 1,000 times 1.1 to the 50th. So that's what's going on over here. And what's going on over here? Well, every time we walk down, we add another term. The term that's all the way on the right-hand side is always going to be 1.1 to the 0th, 1.1 to the 1st, 1.1 to the 2nd, 1.1 to the 3rd, all the way out to n minus 1. So here we had 0th is 1 minus 1, to the 1st is 2 minus 1, squared is 3 minus 1. And I think you'd buy that if we did the 4th line, we'd end up with a 0, 1, 2, and 3 terms of the 500. So let's just write that down. Our C sub n is going to be equal to 1,000 times 1.1 to the n, because this is always equal to that, plus the sum as k goes from 0 to n minus 1, because this is always 0. We add up our return up, we get to, we had 2 on the 3 line, we would have had 3 on the 4 line. So n minus 1 goes here, of 1.1 to the k. Well, this piece right here looks a lot like that sum that we just proved inductively a minute ago. And so I'm going to make that substitution. Now, our normal sum went from k equals 0 up to n, and now we're going up to n minus 1. So where before we used n plus 1 in our in the solution to that sum, we need to subtract 1 from that. So we're just going to end up with n. So we can write down the next line, which is C sub n equals, and we're just writing this down, 1,000 times 1.1 to the n, plus, oh, and I lost my term of 500, so I needed a 500 there. It actually probably technically should have been inside the sum, but you can always move that multiplication by a constant outside of your sum. So now we've got the 500 that I should have written down before, times the times this formula right here. So r to the n, and r is 1.1. So let me just cross that out. Go back to 1.1 to the n minus 1 over r. My r is 1.1 minus 1. And now we're just going to do a little bit of arithmetic. I'll just copy this onto another line. Cn equals 1,000 times 1.1 to the n plus, and then what do we have over here? Well, 1.1 minus 1 is 0.1. Dividing something by 0.1 is the same as multiplying it by 10, and I'm going to just go ahead and multiply this by 10. 5,000 times 1.1 to the n minus 1. Now, earlier, because my phone, which is taking this video, is also my calculator, I figured out that 1.1 to the n is approximately equal to 117. So we now have c to the n, 1.1 to the 50th, which is what the question was asking us for, to the 50th. So c sub 50 is going to be equal to 1,000 times 117 plus 5,000 times, and now we have n, or 1.1 to the 50th minus 1, so that's 117 minus 1 is 116. And then also, just by using my calculator, I found that this turns out to right about $700,000. So if you can, start fairly early in life. Now, and a lot of you are in your late teens, early 20s. So 50 years from now, you will not be that old. If you can, start with a little bit of money and save just a little every year. You can have quite a bit by the time you retire. Although 10% is really not a realistic return. Anyways, talk to you later. Bye.